Hello everyone. Okay, this video is going to be talk about the homework problems. Okay, the homework 9.43 something. Okay, so let's look at the 9.43, right? Okay, the homework problem 9.43. It said there's a three object, and each object is 200 gram, 200 grams. Okay, and this three object has a velocity, and it give you the three velocity vector v1, v2, and v3. Okay, and say okay, velocity vector of each object, and find the kinetic energy of center of mass and internal kinetic energy of the system. Okay, so this problem relates to the formula I showed before. And okay, so now back to this. Okay, so in the previous video I mentioned that okay, there's a equation for your kinetic energy of the many particle system. Total kinetic energy of many particle system is equal to the kinetic energy of center of mass plus internal kinetic energy. Okay, and so for this problem, okay, let's see what's the problem asking for. Okay, so find the kinetic energy of center of mass and the internal kinetic energy of the system. This problem can be done in various ways. Okay, okay, first of all, how we can do is okay. Let's calculate the KCOM directly. Okay, calculate KCOM. Calculate KCOM directly. Okay, center of mass, and then calculate the kinetic energy of the system, total kinetic energy of the system, and then internal kinetic energy is equal to K minus KCOM. Okay, so it's one way to do it, and the other way, yeah, you can calculate the KCOM and the kinetic energy of center of mass, and also you can calculate the internal kinetic energy if you want. Okay, so you can calculate separately or calculate KCOM and K and do the minus, and K internal is to do K minus KCOM. So there are various ways to do this. Okay, so let us try. Okay, I just do as many as many possible as do many way as many as do the calculation as many as possible. Okay, so what's the okay? Let us see what the KCOM. Okay, what's the kinetic energy of the center of mass? In previous video, we showed that the kinetic energy of center of mass is 1/2, and the total mass of system and times the VCOM square, right? Okay, so if we want to calculate kinetic energy of center of mass, you need to know the velocity of center of mass. Okay, so what's the velocity of center of mass? Okay, and the velocity of center of mass is equal to, okay, still remember the formula summation alpha m alpha and summation alpha m alpha v vector alpha. So in this problem, in this problem, we only have three objects. So alpha is equal to 1, 2, 3. Okay, so okay, let's calculate the kinetic energy of center of mass directly. Okay, so that's why that's the velocity of center of mass. First of all, okay, so it's equal to, okay, it's a very long division. Okay, summation alpha m alpha. Okay, so we have two objects. The mass of each object is 0.2 kilogram. Yeah, I still like to use MKS system. Yeah, MKS system, kilogram, meter, and second. So the mass, I just put convert any mass into a kilogram. So 200 grams equal to 0.2 kilograms. And we have three objects. Okay, and the summation alpha m alpha v alpha is very simple. Okay, so 0.2 times, okay, give you the velocity vector of three objects. The first velocity vector is 15J, okay, 15J, there is no I, okay, and the second object is 0.2, 6.7 I minus 3.45J. Okay, so the third object, okay, let me put this here. Yeah, let's say before, it's a very long division. Point I minus 4.32J. Okay, so yeah, it's very, very long division. Okay, and let's us do this calculation. Okay, so actually it's a vector calculation and use the component language. So what's the result? So the result will have two, because we have right now it's a two-dimensional problem. So we have to calculate, separate the calculation in each dimension. So what's okay? So that's this actually is equal to 0.6. This is addition is the 0.6. Okay, so you divide it by, okay, let me write one more equation. Actually, it's 1 over 3 15J plus 1 over 3 6.7I minus 3.45J plus 1 over 3 minus 6.7I minus 4.32J. Okay, so this is a component language, and we have to do the component vector calculation on each component. Okay, so we can treat the components separately. So after all, we have two components. So it's two components. Yes, one is I, the other is J. Okay, what is about I? Okay, the first term there is no I, right? So 0. Okay, and and here we have an I direction, so it's 367, and the second term is here. So second is another term for the I. So okay, so it's 6.7. Yeah, it's very lucky it's 0. Okay, so what about the J? The J component. J, the first term, yeah, this is J, is 15 over 3. And the second term is 3.453. And next term is 4.32 divided by 3. Okay, so what's the result? The center of mass is 0, I plus. Yeah, we have to put a number in there. Okay, let me find my calculator. Wait a minute. Where's my calculator? Where's my calculators? Yeah, where's my calculators? Let's see. My calculator. Where's my okay. Okay, let's see. So, okay, 15 minus 3.45 minus 4.32 divided by 3. Okay, so it's 2.41. It's 2.41. Okay, it's J. Okay, so we have the velocity vector for the center of mass. And okay, we have to do the velocity square. Okay, if you forget how to do the velocity, a vector square, okay, the magnitude square, okay, I just give you a note here. Suppose we have a velocity vector, okay, it's Vxi plus Vyj, okay. So the velocity vector square, okay, magnitude square is equal to Vx square plus Vy square. Okay, so if you forget how to do the vector calculation, it's give you like Hint. Okay, so of course, so we can calculate KCOM. Okay, KCOM is equal to, okay, 1 over 2. And the center of mass, total mass of the system is the capital M is total mass of system. Okay, so it's 0 0.6. It's 0 0.6. Yeah, and times VCON vector n square. Okay, so actually it's kind of very easy, right? So 1 over 2, 0 0.6, and the velocity center of mass velocity is here. So it's 0 square plus 2.41 square. Okay, what's the result? 2.41 square. And times 0 0.6 times 0 0.5. So it's 1.74. Okay, let's take a 3 digit. 1.742, and the unit is joule. Yeah, because in MKS system, the unit of the MKS system is joule. Okay, it's meter, kilogram, and second. So we have the center of mass of the center kinetic energy for center of mass. And so the prob, and then the other part is he wanted us to calculate the internal kinetic energy. Okay, you have two ways to calculate internal kinetic energy. Okay, first of all, like I said, internal kinetic energy is equal to the total kinetic energy of system minus kinetic energy of center of mass. Or you can use the definition of internal kinetic energy in yeah, okay, internal. Oh, okay. Okay, or you can use the definition of internal kinetic energy. What's the definition of internal kinetic energy? It's the sorry, like we have the summation alpha 1 over 2 m alpha, and it's a velocity vector, but it's a relative velocity vector square. Okay, and relative to what? Relative to the center of mass. Okay, this is a relative velocity relative to the center of mass. Okay, so you can have these two ways. Okay, if you go from the left, so you have to calculate the k. You have to calculate the k. What is the k? The kinetic energy of the system. Okay, 1 over 2 m alpha v alpha n square. Okay, so you can do both ways. Yeah, in this problem, I do this way. Okay, I go to the left. Okay, calculate the total energy of the system, and then K minus K COM, and we get internal kinetic energy. And you can try yourself. If you use the definition of internal kinetic energy, you can check the answer. Okay, because I cannot do both. I finally realized I cannot do both because that will make the video too long. Okay, so because the system and the problem already give you the velocity vector of these three objects. Okay, so let me copy this. Okay, because I forgot these three values. Sorry. Let me check. Let me circle this. Let me circle this and copy. So let's see. Paste. Okay, so yeah, move this. Okay. So let's calculate the kinetic energy of the kinetic energy of the system, total kinetic energy of the system. So it's summation alpha m alpha b alpha square. So let's go. Just tell you. Okay, it's 1 over 2 m1 v1 vector. So this should be vector square plus 1 over 2 m2 v2 vector square m plus 1 over 2 m3 v3 vector square. So okay, so then the mass of each particle is the same, 0.2 kilogram. So it's 1 over 2, 0.2 kilogram. And what's the magnitude square of V1? velocity vector. Yeah, just like I said, if you forget how to calculate magnitude square, it's just the component square, add them together. Okay, two-dimensional problems, we have two terms in there. Okay, so this one is 15 square and plus 1 over 2. 0 0.2, what's the V2 square? Okay, it's 6.7 square plus minus 3.45 square. So the last term is 1 over 2, 0 0.2. And what's the V3? It's minus 6.7 square and plus minus 4.32 square. Okay. Okay, so just use your engine, use calculator, find out the value. So this is 0.1, this is 225, and this is 0.1. Okay, and what's the central part? 6.72 plus 3.452. So 56.7925. What's the last term? Last term 6.7 square plus 4.32 square. Yeah, 63.5524. Okay, so what's the total kinetic energy of the system? Okay, that's 7925. And okay, plus 225 divided by 10. So it's 34.534. Okay, that's sure. That's the total kinetic energy of the system. So what's the internal kinetic energy? Internal kinetic energy is the total kinetic energy of the system minus the kinetic energy of center of mass. So it's 34,534 minus what's the kinetic of center of mass? We just calculated 1.742. Oh, so small. 1.742. So the internal kinetic energy 1.742. 34.324. Oh, 4 minus 1.742. Okay, so it will be 32.796, and the unit is also joule. Okay, so that's the internal kinetic energy. Let me check the answer. Did I get it right? No. 0.7. Okay, so this is correct. This is correct. Yeah, this is correct. This is correct. Yeah, I think it's correct. Okay, if there's something, if you found something wrong, just email me or tell me in the class. I think it's correct. Okay. So this is a problem 9.43, right? 9.43. 9.43. Calculate internal kinetic energy and kinetic energy of center of mass. Okay. So just use the formula and just don't forget your vector calculation. How to calculate the vector square. Okay. Yeah. So yeah, I forgot. This should be vector square. It's also vector square. Don't forget the vector square calculation in this problem because it's two-dimensional problem. So it's kind of more complicated than one-dimensional problem. Okay, so just stop video here. Okay, see you in the next video. Bye bye. That's 9.43. Okay.